apologize for that, guys. And ladies, I am still trying to figure some of this stuff out. So as we go along, we'll get it working here. And let me get started on this presentation. I hope that everybody's doing well today. I know we're starting a little bit late, but we will get going on this. And today's topic is going to be on Modbus communication, and there's a lot of confusion around Modbus, and we're going to try to add some clarity to it. And if you have any questions as we go along, please let us know. Again, my name is Brent Palmer. I'm with CRT Services. I'm the manager of measurement technology, and we have decided to bring together a bunch of experts within the measurement community to try to continue the education for these classes and schools that have not happened this year. So one of the things that we're doing is we're having different topics. They're going to be less than a half an hour. We're going to go into some depth on things. Some things are going to be a little bit light, but if you have ideas for topics that you want to go over, if you want to be a presenter and kind of give a class or give a presentation just like you would with doing something at ISHM or some of the other events that we're not going to have this year, we would love to have you, and we'll help you get set up with the meeting and get recording on this. And then after we're done, we're going to post all of these videos online, so on YouTube, so you'll have access to them and hopefully can reference them in the future or share them with other people. And again, we'll take small bites out of topics, so that way nobody's getting bored, but at the same time, we're trying to cover some things that are frustrating for people. And if I say something that maybe you don't agree with, hey, raise your hand also and give me another perspective on things. So really appreciate everybody joining on today, and those that haven't joined live. We hope you find this also informative. So we'll go ahead and get started. Modbus communications, what do we use it for? Well, it's a protocol, and I'm not going to read through everything that's on the screen here, but basically it's a master-slave protocol that's been around since '79. And we use it a lot for communications between devices. So we may use Modbus between a PLC and a flow computer, or Modbus between a flow computer and a Coriolis meter, or Modbus from a SCADA system to another device. And we're just going to go over what a Modbus message is, what it means to be a master or slave or server or client within this protocol, and how it works, break it down a little bit, and then do a little diagnostics so you can see what's going on. And it's really a helpful troubleshooting tool if you're able to see the Modbus messages and break them down just a little bit to determine where you're at. Because a lot of times we spend hours upon hours working out communications because of what is supposed to be a Modbus standard and what the manufacturers have actually implemented in some cases. So we'll go ahead and get started. Modbus Standard. There is a standard, but there's not a standard. And the reason I say that is that what you'll find as you go to different industries, different programmers, different manufacturers, that what people think is a standard is not really a standard. And what I mean by that is I may say a float is 32 bits, and a float is 32 bits. But the way that the message gets transmitted back and forth may be in two 16-bit registers instead of one 32-bit register. So just because I call something a float or somebody else calls it a reel may not mean that the way that we retrieve the data back is identical. And what happens is a lot of times we see this implementation of PLCs and some other devices that say, well, you know what? We've got these Modbus addresses, and if you're going to use a coil, which would be like a statement of a 0 or 1, I'm looking at the status of something. So typically, if I'm looking to see if a pump is running, I may have a register that says pump is running. 0 is false, and 1 is true. So when we talk to some of the manufacturers or talk to some programmers, they'll say, well, it's a coil, so therefore the coils all have to be in registers 1 through 9,999. And I have to read them out of there. And you'll see that Analog input registers have to be between 30,000 and 39,999. And holding registers, which we would use for totalizers or something, are all going to be in another grouping of registers. But what we find is manufacturers put them all over the place. So there's not a true standard that says, well, if I need to go get a live flowing temperature, then I'm always going to find it in these 30,000 registers. What we get is we get a mapping from the manufacturers that tell us what those registers are and where they are. So what we're going to go over here is specifically what a register is, how it's broken down, and how that Modbus structure or how that Modbus text is broken down coming back. All right, let's see. So information is stored in a slave device in 4 different tables. 2 tables store on and off discrete values, coils, and 2 store numerical values, registers. The coils and registers each have a read-only table and a write table. So when I look at the Modbus definition, this was pulled right off of modbus.org of why they're, what a register is and how they're stored. This is the information that you see. But again, when I go talk to a manufacturer, Micromotion, their registers are not stored in this function. When I go talk to FlowX or an Omni flow computer or something else, they're not set up in this structure. They're all a little bit different in the way they set them up and the way that they store them. So we're going to try to get some clarity to this. So a coil numbers can be thought of as a location name since they don't appear in the actual message. For example, the first holding register number of 40,001 has a data address of 0. So what that means is we have a holding register that people call 40,001, but the actual data register, when I pull a register, I need to pull 0. And that's if it's 0 based, or 1 if it's 1 based. So this holding register, even though they're holding it in their device, maybe in a 40,000, the actual communication that we're asking for, I can't ask for 40,001. I actually have to ask to this device, I have to say, give me address 0. Because when I'm pulling for something, I'm asking for information. Kind of think of it like if it's serial or if it's Ethernet, think of it like a telephone. Okay, but it's a one-way street telephone, and I can't talk at the same time. So basically, I have to ask a question, and then I have to wait to get a response back. If I look at the way that this is set up in this first example, I'm thinking in my head, I want to know what's in to put in my holding 40,001. But what I really need to ask the person on the other line is, I need to say, give me address 0. Because in this case, this is a 0-based system, and they start off with, and they put the information in address number 1. And that's where a disparity can come in, because some of these PLCs and polling systems actually will say, well, I need 40,001. But when you look at the hexadecimal value that they're asking you for register 0. But you've set up your whole communication structure as 40,001, 40,002, 40,003, but that isn't what they're asking for at all. So it creates some confusion as we start looking at this information. And I'll go into some more examples here. So another example is the difference between the 2 values. In this one is an offset, and there's an offset of 1. So we talked about that 1 that we were asking for a 0-based system. In this case, it was a 0-based system, but we can also have a 1-based system. So I need to start off, even though they're asking me for register 1, I have to interpret that they're actually asking for register 0 because they think I'm a 1-based system. And I know this is completely confusing, and it's confusing for me too. And we spend a lot of time when we're talking with PLC programmers or SCADA programmers, people that are not familiar with our equipment that we utilize. And they struggle with trying to tell us exactly what they're looking for. So a lot of times what we'll do is we'll say, hey, go ahead and pull us, and then I can actually see what's being requested. And again, we're going to get into an actual polling, what happens here. So one of the first things when we come in is we have a slave ID that we're pulled for. Modbus devices, you have to have an ID. Why do I have to have an ID? Well, I've got to know if I have multiple devices on a system, which one are you asking the information for? So imagine if I have an old party line. Well, a lot of you won't understand what a party line was, but back in the day, there used to be telephone systems where if you lived on a street, there was only one phone line, but each house had a distinctive ring, a slave ID. So if a phone call was for your system or for your house, your phone would ring a certain way. Everybody's phone in the whole street would ring, but they knew a certain ringtone or a pattern of rings was for a particular house, and that person would pick up the phone and talk. Problem was, everybody else could pick up the phone and listen too. The same thing here. Every device that's on the system is listening into all of these communication, but it has to determine that the message that you're asking is directly for it. So if I just sent a broadcast message out and said, I need register 7101, I would get every device coming back answering with 7101, but I wouldn't know where it came from, even though they're all listening on the system. So what we do is we assign a Modbus slave ID or an ID itself. And that way I can direct the messages to the device I particularly want to talk to. Another layer to that would be is if I have Ethernet IP communications. That device I want to talk to has a unique IP address, and then it has a unique slave ID. The IP address is set into the device itself, but I still have to have a proper slave ID if I'm talking Modbus to it. So slave ID is very important, and there's a restriction that you can only have addresses from 1 to 247. So obviously I can't put 250 devices on the same line. Another downside to putting things on a serial line where we've multi-dropped them is if one device starts to have a problem screaming on the line or it's taking the system down, it also takes down the rest of the devices on that multi-drop line, or has the potential to. Not that it happens all the time, but it's just a possibility that you need to look at when we lose communications to something. Are there other devices that are on that line that are causing us to go down, that there may be one device that's pulling the whole system down and you have to isolate that? So slave ID, and then we have function codes. Function codes are basically in this message that I'm sending, what am I doing? Am I asking to read something? Am I asking to write something? Am I writing just a single register? Am I writing multiple registers? Am I reading multiple registers? Are they coils? Again, coil being a status where I'm looking for a 0 or 1, let's say, or am I writing down or reading whole registers back and forth? So with Modbus, we have a sequential list of registers, typically. So if I have coils, let's just keep it simplistic, and I have a pump start, a pump stop, a valve open, a valve close, 4 registers. I can ask for the status of all those registers. So I would say, okay, slave ID number 1, I want you to function code, we want to read multiple registers. So a function code, let's say 1. And I want to read these coils, and I want to see what the status is, and I'll ask for a certain number of registers. So I'll say 4 in this case. So when I write this down to it, my request will be 01, function code 01, and then I'll ask for a starting register 01, and the number of registers 4. And the device will turn around and give me 4 consecutive registers. When I do that request, I can't say, well, you know what, skip register 2 and 3 and just give me 1 and 4. I have to take back the whole sequence when I ask for multiple registers. Now, if I want to just register 1 and 4, I can poll register 1 and register 4, but that's 2 separate polls, which means that I have to ask for the data. I have to then wait for it to receive it back, and then I have to ask for it again, and then hopefully I'll receive it back. So it takes more time in trying to get the information back instead of reading a whole list. Now, a lot of times what we can do also is we can ask for the whole list, and then on the master side, when we get back 50 registers, I may only need 3, and I'll just parse out or look for those 3 registers in the reply back and just use that information and discard the rest of the information. It can be more efficient. But what it does is it makes a larger response, more data packed into the response coming back. So in the old days, we really had to worry about the bandwidth. We still do to a certain extent, but how large these messages were, how frequently we were pulling information. So, so the second byte sent by the master is the function code, and this number tells the slave which table to access and whether to read or write from the table, which we just explained. There's also a CRC check that comes in. It's a redundancy check. And what it's used to is to make sure that the messages being received and being asked for don't have errors in them. So if we get an error in them, the CRC check will tell us that there was something not transmitted correctly. This comes into play a lot too. When we think about Modbus communications over TCP, we're packing data in. But when you're looking at 45 and 232, the way that we are communicating is basically a pulse, a digital pulse coming in. So we're looking at voltages. And if those voltages were corrupted coming in, that the message was incoherent, we wouldn't be able to get all the information back correctly. The CRC would not be correct. So do we have something going on the line that's maybe causing us to have an issue? So the data types that we typically have coming back are 16-bit unsigned integers. Integers typically we bring back as registers. We can have 16-bit signed, and what this means is, or do we have basically with these registers, do we have a positive or negative to them? So you can see an unsigned register is from 0 to 65,535. And a whole number is between -3, the 32,000 to positive. It's still the same physical number. Basically, I can have 40, I can have 65,535 numbers numerating up, but I can't go larger than that because that's the maximum a 16-bit piece of information can hold. So if I go negative to positive, it's still the same 65,535. Because that's as large as that number can be from positive to negative. I can also have ASCII strings. I can have my coils, my discrete values that are packed into integers, where we can take an integer, which is 16 bits, and use it as a binary code to pack 16 coils inside. I'm just going to continue on. A 32-bit integer. So now we have, instead of a 16-bit, we've got 32. And we can pass those along as 2 16s or one whole 32-bit. But there's something to note in here. There's a limit to what these registers can be. And I bring that up because a lot of times what I'm seeing now, and it wasn't something that was done typically in custody transfer for flow computers, was that now we're asking for the total pulse counts coming off of flow computers, which is great. We want to see the total number of pulses that have been generated in that flow computer. But I'm bringing those back as a 32-bit integer, which means that over time, the biggest number that I'm going to be able to get is basically 2,147,000. So once my pulse accumulator goes above that, once my volume totals, once my mass totals go above that, I can't transmit a number any higher because I'm using a 32-bit integer. So I have to create rollover values inside to make sure I roll these numbers over before they get over 2,147,000. So if you ever get a call and somebody says, hey, I'm looking at my totals, I'm looking at something, and it's stuck at 2,147,000, that's just a key that says, you know what, you've maxed out that register. The register in the device may be larger, but that's all you're able to give back at this time. What also is confusing inside the Modbus is we have byte orders. You would think that when we bring this data back, that if I have these hexadecimal bytes coming back or these values coming back, that I would read them 1, 2, 3, 4. But what actually happens is we start storing these numbers back in, whoops, sorry about that. We start storing these numbers. Let's say I've got a number that comes in and it's AE41. Well, in one case, we've got a high-low bit, or we've got reverse bits. And what they do is they put the 41 before the AE. So you have to know when you're getting this information back, one, what's the byte order? And number two, when you have these bytes, they create a word. Are the words swapped? Is it the large word first or the small word first when we're looking at the data coming back in? And I'm going to present another series on this information and go into a little bit more detailed on this to kind of make some an explanation of this. But what I really wanted to get to in kind of the background on this was the framing of a Modbus message when we see it. So when we look at the Modbus message coming back in, we'll see a message like this in hexadecimal value by a decoder. And this is what the flow computer is actually seeing, or your other device. It's seeing this message come back in. And what it's doing is it's breaking down this message that it just received, and it's saying, okay, you know what? In this message, the first two are going to be my slave ID, in this case, 2. My function code is 3, and I know my function code 3 says to read registers. The starting register is 1BBD. And then I'm going to read it for a quantity of 000A. Well, if I look up and try to figure out what these are, I can actually see what register it's asking me for. Whoops, and we went too far because I was going to show you how to do that. The way that you do that is Microsoft has given you a really good little programmer tool. And it's just in your calculator. Normally, you're running a standard calculator. But if you go up top and go to the left and go to Programmer, and I'll push this off to the side just a touch, but let's say that starting address, I don't know what it is. Well, if I click on hex and put in 1BBD, when I look at my decimal value, that tells me, hey, that's register 7101. Well, how many is it asking for? Well, it's asking me for A. I'll clear out my hex. And I'll put in 0A. Oh, it's asking me for 10 registers. So I know that the message I just got was, hey, if I'm Modbus ID 2, I want to read some registers by the function code 3 with a starting address of 1BBD 7101, and I want to read 10 registers. And in turn, if I do that, the flow computer is going to respond, or the device is going to respond with a response doing that. And this is an example. This is a tool that's out there that's called Simply Modbus TCP. And we'll go ahead and connect to a device. And I have slave ID 1. And I'm going to read register 7101 for 10 registers. Now, there's not going to be an offset. An offset would be if somebody said, oh, you need to read the 40,000s. But what they really mean is read 47,101, but put in an offset of 40,000. So we can actually read the registers that you're looking for, but we're not going to do an offset here. There's going to be a 0 offset in this because I specifically want to read register 7,101. Now these registers are going to be 32-bit, meaning that each register is 32 bits in size. You can have registers that are 16-bit in size. So I could change this and say, no, these are all 16-bit registers, but I still need to add them together to create a 32-bit float. And I've got a couple chats up here. Oh, you guys can only see the PowerPoint. Sorry about that. Let me try to change my my screen share here. There we go. Appreciate that. Hopefully everybody can see that now. Perfect. Okay. So I've connected in. I'm going to read register 7101 for 10 registers. My function code is going to be 3. And these registers, I know inside the flow computer, are 16 or are 32-bit floats. So my request going into the flow computer, ignore the first part here of this request because it's TCP. I'm going to ask for 01, which is register, which is slave ID 1, function code 3, 1BBD 000A for 10 registers. So when I hit send, it's going to error out because I waited too long. And we'll go ahead and shut this down and bring it back over. Hold on one second. And then I'll bring the window back here. And let's see if I can disconnect and reconnect again. And then we'll send it. And now you see I get my information populated. So my results coming back, my bytes, the way that they came back, 44, E1, and then zeros, which I have a setting down at the bottom here that says I know the high bit is first and the high word is first. So I'm bringing back this information. Now, what if I wanted to bring back the totalizers? Well, I know the totalizers are in the 5,000 registers. And I'm going to bring back 10. They're still 32-bit registers, but these are 32-bit integers. And I'll copy that down. And now when I hit send, I'll see the results of my registers coming back. So I get my poll. Now I'm at 13 ED, which is 5101. And then I get this long response of data back.
Hey, Brent, we can't actually hear you anymore.
Can everybody hear me now?
Yes, sir.
All right, sorry about that.
You kind of have to go back a few slides. We have no idea what was going on.
Oh, okay. Let me go back. Basically, what I was doing is I was just polling for information. So I went to, in this case, I went to integers, and I pulled integers instead and brought back, for some reason I'm having a problem, but I brought back the integer data instead of bringing back floats now. And it was just basically saying that I have a high word and a low word the way the data was coming back. But the poll that I'm looking for is this 01, which is the ID, 03, which is the register or the function code, and then the starting register of the 13 ED, which is 5101, and I'm still asking for 10 registers. And I'm going to stop sharing that for a second, and I'm going to go over to start sharing my my main screen here. And hopefully everybody can see that screen. We'll get out of that real quick. We're going to share. There we go. So there are communications analyzers that are built into some of the flow computers. And in this case, if I look at and start recording the data coming from a Modbus master, what you'll see is I have a request going out. So the outgoing information is going out in red, but I'm not getting a reply back. And if I stop that for a second, I can actually break down the message and I can see, what is this thing asking for? Well, it's asking for Modbus ID 1. It's asking for function code 03, and it's asking for 00F4. And in 00F4, if I look at my hexadecimal value, is register 244. So I know it's asking for register 244. It's asking it for so many, but I'm not responding back. And I may not be responding back on my device because it's a bad Modbus ID. It actually, the device is set up for Modbus ID whatever. So just kind of a breakdown on the structure of these registers. I apologize for the issues we've had with the sound quality and kind of getting in and out of the equipment here. we're still in the process of learning how to do this. We hope that it's productive. We hope that everybody's learning something from this. I've got about 4 minutes left. Are there any questions that anybody has, or any comments that they would like to make? They can unmute their microphone, or they can type those down if anybody has any questions.
Hey, Brent, this is Mark and Bernardi here. Can you hear me?
Yeah.
Awesome. Hey, I'm more of the process mechanical guy, and I'm diving into this because it's something I just need to know at some point. Modbus, what else do you use besides Modbus? It sounds like Modbus for flow measurement is popular or widely used, but what other communication protocols, me being totally new and green to this, are out there that I'll find in?
Well, there is, let's say for instrumentation, there's HART communications, which
Okay.
HART is still a Modbus type protocol, but it rides on an analog signal. You also can use OPC, which is basically more of a tag client protocol. Ethernet IP allows for information to be shared across. So there's a lot of different ways that information can be shared, but in our industry, most typically everything is done Modbus or Foundation Field Bus. It's all just communication. We actually, with the FlowX flow computer that we use, a lot of times the information that we get is what we call tag based. So we do these little web queries, and when we ask for information, we're asking it from our web services. So in this case, what I just did, and it's a very intensive request that I did, but I said, hey, in the flow computer, can you please give me back every single tag inside of it? And it's brought back as XML. So I bring back what the holding tag inside the flow computer is, along with its value and its information coming out. So there are also other communications like that, but probably 99.9% of the information is still passed by Modbus, which is from 40 years ago. Reliable way of communicating.
Thank you. So
You're welcome.
HART and Modbus, if I'm an Emerson guy or all that for, a 3051 transmitter or whatever, like I know that's where I see HART the most. So HART is a subset of Modbus, or a particular style of Modbus almost.
Yeah, the difference is it rides on an analog signal instead of riding on a digital signal.
Okay.
But it still uses registers and codes and replies coming back in that structure.
Okay. Thank you.
You're welcome.
Hey, Brent, you have a question on chat about everybody's asking to see how to get the programmer function on calculator. That portion wasn't shown.
Sure. Let me see if I can share that again. I apologize for not realizing that this was not showing up. So can everybody should be able to see the programmer now?
Yeah, we can see it.
Okay. So normally you're set up as a standard programmer like this, or a calculator. So in that calculator, I can go and I can change it to programmer. And then when I break down the Modbus message, I can click on hexadecimal, and I can say, when I said I was looking for how many registers, I put in 0A, and it gives me the decimal value. Or let's say that I wanted register 7101. I can clear out this value and put in 7101, and this is the hexadecimal value that I should see for 7101. So it's a really handy tool. It breaks it down into binary for you also. So if you're trying to break down 16-bit binary,